In this video, we're going to discuss how we solve linear equations, a little bit more complicated. And I'm going to give you a general strategy that you can use to solve any and every linear equations. These are some steps that I take. The first thing that I do is I simplify both sides of that equation. Now, what I mean by simplify both sides is one of three things, all right? Use the distributive property, combine like terms, or clear fractions. That's what I mean by simplify both sides. After I'm done simplifying both sides, now you know you're going to be working with each side individually in that step. Now I'm ready to work on both sides of the equation using the multiplication and the addition properties. All right, we're going to get our variable terms on one side of the equation, and with that, we're going to also get our constant terms or our numbers on the other side of the equation. In this step, we're either going to be adding or subtracting. Okay, adding or subtracting. The last step before I check my solution is to isolate my variable. In that step, I'm actually going to be using multiplication or division. All right, so we add or subtract first when we do solve linear equations, and then we multiply and divide second. So it's a little bit different from your order of operations, but this is what we do. And after we isolate the variable, get it on one side completely by itself, we can always check our solution by substituting into the original equation. Let's look at an example. All right, part A, we have 10n minus 95 equals 80. All right, that first step says to simplify both sides. All right, so I'm going to look at both sides individually and see if I can distribute, combine like terms, or clear any fractions. If I look at both sides of this equation, I can't do any of those. Both sides are already simplified. So I'm going to go to step 2. It says to get your variable terms on one side of the equation. Well, I don't have a variable on both sides. My only variable, which is n, is on the left-hand side. So I'm going to get that variable term on that side, but I'm going to get my constant term, which is that minus 95. I need to remove that from being on the same side as that n. So what I'm going to do is I'm going to add 95 to both sides. I'm definitely going to be left with 10n. These two cancel. And 80 plus 95 is 175. All right. Now I'm done with step 2. So step 1 is gone. Step 2 is gone. Now we're going to go to step 3. This is when I completely isolate the variable. This is when I do multiplication division. All right. I have 10 times n. The operation between that 10 and that n is multiplication. To isolate it, I've got to divide both sides by 10. So I get n equals 175 over 10. Now, if you look at 175 over 10, they have a common factor of 5, right? I think 35 times 5 is that same 175. So if I divide 175, I get 35, and if I divide 10 by 5, I get 2. And so this is my answer in simplified form. And so I could go back, substitute into my original equation, and make sure that I get the same answer. Due to space, I don't have enough space, but if you substitute the 35 over 2 into the equation for n, you will see that that is your solution. All right, let's look at another example. Part B, we have 6x plus 19 equals 3x minus 8. All right. Again, the first step is to simplify to see if you have a distributive property, combining like terms, or clear fractions on either side or even both sides. Sometimes they're on both sides. I don't have that in this problem, so I'm going to go to step 2, which is to get my variable terms on one side and my constant terms on the other. All right. Now, I have x's on both sides. I'm going to pick a side. I usually pick the side with the larger variable term, like the 6x is definitely bigger than the 3x. So instead of having this 3x on this right-hand side, I want it to be on the left-hand side, so I'm going to do the opposite of that positive 3x, which is a minus 3x. So I'm going to subtract 3x from both sides. 6x minus 3x is 3x. The 3x's cancel, and I'm left with negative 8. Now, I'm not completely done there because I still have this 19, so my variable isn't isolated, or my variable term isn't on one side by itself, right? So I'm going to have to subtract 19. That's the opposite of adding 19. From both sides. All right, I'm going to be left with 3x, the 19's cancel, and negative 8 minus 19 is negative 27. Now I see that my variable term is on one side completely by itself. All right, my last step is to isolate the variable. Since that's 3 times x, I'm going to divide both sides by 3, and I'll get that x equals negative 9. All right, and so that's the solution to that equation there. Again, you can check your solution by substituting negative 9 in for x, this term and this term right here. Simplify it all out, and you'll see that it is the same. Let's look at another example. Part C, we have 3 times of 2x minus 7 plus x equals 2 times an x minus 9 minus 18. In this example, we have a distributive property on both sides of the equation. So what I'm going to do first is I'm going to distribute the 3 here. 3 times 2x is 6x. 3 times a minus 7 is minus 21. I still have this plus x here. And on my right-hand side, I have to distribute the 2. So I'm going to have a 2x minus 18. And then I have that minus 18 there. And notice this minus 18 here came from the 2 times that minus 9. Of course, I have like terms. And so 6x plus x is 7x. So I get 7x minus 21 equals, well, these minus 18s combine to minus 36. And now I have an equation that looks very similar to the last equation that we just did, where I have variable terms and constant terms on both sides of the equation. Well, I'm going to pick my left-hand side for my variable terms to be, so that means I have to get rid of this 2x by subtracting 2x from both sides. And I'll get a 5x minus 21 equals a negative 36 because those 2x's cancel. Of course, I want to add 21 to both sides so that I can get the 5x on one side by itself. And so I get 5x, these cancel, equals negative 36 plus 21 is a negative 15. All right, I can divide both sides by 5 to completely isolate my variable, and I'll get the x equals negative 3. All right, and so I've completely solved that, and this is one of the type of examples that has everything in it. And so this is a good example for you to really know how to do. Let's go to another example, our last example that we're going to look at in this video. And it's part D. It's 1/10 x minus 2/5 equals 1 over 20th x minus 7/10. All right, and we want to solve this equation for x. All right. Well, we have fractions in this example, and when we're working with fractions, it makes things a little bit more complicated. So what we're going to do is, instead of working with these fractions, we're actually going to clear these fractions. All right, in order to clear fractions, we have to find the lowest common denominator. All right, and if I look at all of these denominators, I have 5, 10, and 20. All right, least common multiple of 5, 10, and 20 is actually 20. All right. And so what I'm going to do is I'm going to multiply both sides by 20. Excuse me here. I want to multiply both sides by 20. And I kind of messed up here and I can't erase it. So this side is going to be multiplied by 20, and this entire side here is going to be multiplied by 20. Okay, that sets up a distributive property, and I'm going to write it out right now. This is going to be a 20 times 1/10 x minus 20 times 2/5. All right, because I got to distribute, equals 20 times 1 over 20 x minus 20 times 7/10. Okay. And so with this, I've got to simplify, right? So 10 and 20, they have a common factor of 10. 10 goes into 22 times, so I'm going to be left with a 2x. Now I no longer have a fraction. 5 goes into 24 times, and 4 times 2 is 8, so I get 2x minus 8. 20 goes into itself one time. 1 times 1x is just x. And 10 goes into 22 times. That's a negative 2 times 7, which is a minus 14. All right? And now this equation looks very similar to the last equation that we just did. And so I'm going to go ahead and continue to solve. I'm going to say that I want my x's on my left-hand side, so I'm going to subtract x since this is positive. Got to do the opposite. And so I get x minus 8 equals, those x's cancel, and I have a negative 14. And then last but not least, I want to add 8 to both sides. And we end up with x equaling negative 6. All right, and this concludes our video on a general strategy to solving linear equations.